stats. The out of order unit, unit 6. So is this a distribution, a probability distribution? Why or why not? Well, let's look at the numbers. Less than 1, positive. Less than 1, between 0 and 1, all of these. If I type these in the calculator and add them up, or just do it in my head, 26 cents and 9 cents is 35, plus 15 is 45, 50 cents, 60, 70, 80, 90, 100. They equal 1.00. So yes, it is a probability distribution. Now the expected cost. This is a little bit different than the way we've done it before, but it is the same thing. You're going to take and multiply each of these and then add them. We'll tie this into another problem a little bit later, specifically number 91. But you may not remember it this way, but it will make sense later. So 20 times 0.09 plus $40 times 0.26 plus $60 times 0.15 plus 80 times 0.2 or 0.20 plus 100, I don't know why I just put that line there, times 0.3 or 0.30. So this is 1.8, if you want to do it separately, 10.4, 9, 16, and 30. And if you total those up, you get $67.20. And again, remember, we'll tie that into number 91. Explain why the following distribution is not a probability distribution. Hint, there's 3 reasons. Well, here's number 1. It's greater than 1. Here's number 2. It's less than 1. It's negative. Can't have that. And number 3, it equals 2.37. And it's supposed to add up to 1. So there's your 3 reasons. Okay, the z-table. Area under the curve. Okay. Hold on, technical difficulties. Alright, so here we go. Use the z-table to find the area of the curve for less than 1.60. So I go to my table, which you'll have in the final, and this is the negative side. So I'm going to turn my page over, and we go to 1.60. So where is that? Well, here's 1.6, here's 0, so 1.60 is right there, 0.9452. 0.9452, which as a percent is 94.52%. Now, greater than 2.21. As soon as I see this, I'm going to write 1 minus. Because remember, this graph shows you everything left of the z-score. And if we want everything greater than that z-score, we need to subtract out the area we found. So it's at 2.21. Well, where is that? Well, here's 2.2. And 2.21 is right here. 0.9864. So we're going to subtract out 9864. Which leaves us with 0.0136. Or 1.36%. So not much of a chance. Less than negative 0.73. You gotta be careful with this one because now we need the negative side. Negative 0.73. Well, here's 0.7, and here's 0, 1, 2. This is the one we want right there. 2327. 0.2327. Which is 23.27%. All right. Team's score was 48 points, the average, with standard deviation of 4. What's the percentages between 36 and 52? Well, this just means we got to do two problems. And remember, we take the actual score minus the mean divided by the standard deviation. And we do that again. 52 minus 48 divided by 4. And when we do that, we actually end up with no decimals. We end up with -3 here and +1 for a z-score. Which is nice. So what I do is, I can actually, don't have to use the z-chart. I can go right here and say I'm going between -3, so here's -1, here's -2, here's -3. So I'm going to go from here through here. All I need to do now is add up 34 plus 34, which is 68, plus 13.5, which is 81.5, plus 2.35. I'm basically just adding up the areas between -3 and 1. Now, if I had, -3.1 and 1.57, then I have to look those numbers up here and then subtract out the two amounts. But I don't have to do that here because they're whole numbers. So when I add all those numbers up, I get 83.85%. Now, I'm going to do 52 minus 48 over 4, which I already know is 1. Same problem. And then 60 minus 48 divided by 4, which is +3. So I'm going to go back to the same concept here. Not what I wanted. Except this time, I'm going between +1 right here, and here's 2, here's 3, right here. So now I just need to add up those two numbers, 13.5 and 2.35, which gives me 15.85%. All right. Home run totals for 14 years of this kid's career. Find the mean, median mode, mean, median, standard deviation in your quartile range. Let the calculator be your friend. So, in this case, we're going to turn it on and go to Stat. We're going to edit. So we hit Enter. Now remember, if there were numbers here, like so, I can overwrite them, or I can go up to L1 and hit Clear. Now it doesn't look like anything happens. When I come back down, it's empty. And now all I'm going to do is put these numbers in. 18, 22, 21, 28, 30, 29, 32, 40, 33, 34, 28, 29, 22, and 20. Now remember, carpenters measure twice, cut once. We're going to check our data twice before we calculate. So I'm just going to go backwards and look at what is in the calculator and what is on the paper. So 20, 22, 29, 28, 34, 33, 40, 32, 29, 30, 28, 21, 22, 18. All my numbers match. Now, I go back in to Stat. Whoops. I hit second Stat, sorry. Go to Stat, go to Calculate. And all you do is just hit Enter, 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 because it's already set up for L1. And here's all my information I need. My X bar, my average, is 27.57. My median, I just need to scroll down. There's my median right there, 28.5. My interquartile range, my standard deviation, hold on, is one of these two, SX or OX, theta X. So either 6.3 or 6.03. Either one would be acceptable. And in the interquartile range, remember, we look at Q1 and Q3. Q1 is 22, Q3 is 32. So the interquartile range is 22 to 32, or simply 10. Either answer is okay. That's all we need there. Okay, 91. Remember, this is why I said we're going to look at the table again, or compare it back to the earlier problem? Well, here we go. So, number of days. First we need to add all these up. And when you type these in your calculator, you're going to get 100, which works nicely because now the probability of 16 days is 16 out of 100. That's simply 0.16. And then 0.19, 0.15, 21%, 9%. Be careful. I just put my decimal in the wrong place. 0.09, not 0.9. And then 0.10 or 0.1. 0.08, don't forget that 0, and 0.02, don't lose that. Those are all my probabilities of each of 0 sales, 1 up to 7. Now, what we do is we take this number times that, and we get 0. And 1 times 0.19, and 2 times 0.15, and so on and so forth. 0.63, 0.36, 0.50, 0.48, and 0.14. We've done that before. That is the same thing as what we did right here, or actually right here. Multiply them out. Okay? And then we're going to add those up. 2.6. The expected value, okay, or the expected mean is 2.6. That means it's right here in between 15 and 21. Alright, so what it's saying is the average is right there between 2 and 3, which makes sense. If you look, a good part of the data is right there. A large number of it is right there. Okay, 19, 15, and 21. That's the bulk of the days. So it makes sense that 2.6 would be somewhere in there. Now, what's the probability of x of less than 4? Well, here's 4 right here. The probability, we're basically going to add up those numbers. 9%, 21%, 15, 19, and 16. And that's going to add up to 71%. Which makes sense. That's the bulk of it right there. That's almost 3/4 of the data right there. Greater than 5? Well, that's just going to be right here. 0.08 plus 0.02, which is 0.10, which is 10%. Okay, is this distribution normal or skewed? Well, to be normal, you would have to have, something like this over here. Something close. So where you have this big part in the middle and kind of the same on either side. But we don't have that, which means it is skewed. Now, which way is it skewed? It's skewed to the right. Remember we said follow the tail. So the tail is over here. Follow that. That's where it's skewed. It's skewed right. Now, what does that mean for the mean and the median? Well, the mean is greater than the median. Now, if you can't remember that, but you have time, one question like this, you can real quickly go into stat, edit, and put these numbers in real quick. So you have how many 20s? 1, 2, 3, 4, 5, 6. You have 6 20s. So 1, 2, 3, 4, 5, 6. And then you have 5 22s. And 6 24s. And 3 26s. 2 30s. 132, 134, and 136. If you want to take time, if you want to make sure you got this answer right, because then all you do is go to stat, calculate, and then check out the mean and the median. The mean is 23.76, and the median is, let me check here. I think I made a mistake entering because I was in a hurry, which I shouldn't do. This is why you check twice, because this was supposed to be 22, and I did not check that. I ignored my own rule. So 24, make sure those are all there. Yep. My 26s should be 3 of them. Then my 230s. There we go. Now, when I run my stats, that didn't make sense. The numbers are backwards. And there it is. My mean is 24.56, and my median is 24. So if you want to make sure, if you couldn't remember which one means which, the mean is slightly greater than the median. What effect do the outliers have on the mean? Well, think about it this way. If most people had a score down here, but a few people got a score up there, what is that going to do? Well, follow the tail. It's pulling it to the right. So it is raising the value. Or pulling to the right. Okay? That's the effect it has. It's pulling up. It's making everything better. Okay, 93. Algebra classes. You had an average of 78% with a standard deviation of 3. That's on the first test. On the second test, the average was 87 and 2% standard deviation. Brian got an 84 and 92. Which did you do better on compared to the rest of the class? Well, remember, it's the actual score minus the average divided by the standard deviation. Actual score minus average on the second test divided by the standard deviation. When you calculate that, you get 2.0 and 2.5. Which do you do better on? He did better compared to the rest of the class on the second one. And that is it.